Bob Roth, President and CEO of RoMan Manufacturing, and on behalf of the entire team, I'd like to welcome you. I know that when you can come and visit us and see what we do, it shows us at our best. I also understand that you're not always able to do that. So today we'd like to bring that tour to you. So why don't you come on in and let me show you what we do. So before we start that plant tour, I thought it'd be a good idea to tell you a little bit about what we do at RoMan Manufacturing. So RoMan is a designer and manufacturer of electrical transformers and power supplies. And we service machine tool builders and system integrators, any manufacturing process that uses a high current and a low voltage. And our transformers are the device that converts the electrical energy from the higher voltage to the lower voltage, but also from the lower current to the higher current. Resistance welding is a very important industry to RoMan Manufacturing. It is really the cornerstone on which we built our business. And our transformers are used in most automotive resistance welding facilities around the globe and many other forms of resistance welding. But transformers, whether they're the transformer on a pad outside of a factory, the one on the pole bringing power to your house, the little transformer that might have been a part of your model railroad system, or the transformers we build, all have three important and critical components: a primary winding, a secondary winding, and a magnetic core. And I'd like to show you what those look like in the RoMan transformer, so when we go see the actual manufacturing processes, I think it'll help make it a little clearer. So for us, the primary winding looks something like this. And it is copper wire, typically called bare copper flat wire, and it is wound into a coil using different insulating materials. The secondary winding of our transformer is actually a fabrication, and it looks like this as one example, or like this as another example. It's made up of copper extrusions, copper casting, and copper bus bar. It's a fabrication because the unique element of our transformers is that they're water cooled, and the water cooling is carried in the secondary of the transformer. This is the low voltage, high current side of the transformer. The third component that every transformer needs is a magnetic core. For us, it comes in two forms. One is what's called either a wound core or a hypersil core, and it's strips of electrical steel wound into that fashion, or electrical steel stamped into laminations. Looks like this. And then I also mentioned DC power supplies. A DC power supply needs a rectifier, and rectifiers can look something like this, which are copper chill blocks with high current devices in between those chill blocks under great clamping pressure. So the product, when it's complete, looks something like this. And these transformers here are actually mid-frequency DC power supplies, and they're used in automotive resistance welding. Most automotive welding today is done with DC. This transformer, along with the resistance welding gun or the spot welding gun, is mounted at the end of the robot and manipulated to form up the car body, which is known as the body in white. Another thing that we do at RoMan that I just wanted to mention, we don't do it here at this facility, but at another facility we have a non-ferrous foundry, and we pour copper castings and aluminum castings. We use about 30% of the foundry's production into our own product and then sell to the broader marketplace. I have some examples here of those types of castings. Here's a copper casting. And here's two different aluminum castings, again, all done at our foundry. So now let's take a look at the way that the primary winding is manufactured. And behind here, you can see that there are layers of copper and insulating materials wound on a mandrel that form the primary coil. And one of the critical things about a primary coil is to get the number of rotations of copper precisely correct. It's that ratio of turns on the primary to turns on the secondary that allow the transformer to perform appropriately. And here you can see a couple of different sizes of coils that we wind. And again, the principle of how they're constructed is the same, always on a mandrel. layers of copper, different widths and thicknesses, layers of insulation, in this case, Nomex. What the coil winder is working off of is called a data sheet. And I have one printed out. They're working off a digital copy of this, but it gives them all the information they know to construct the coil properly. The mandrel size, what copper wire to select, the insulation to select, and again, most importantly, the number of turns. And that's how we produce a primary coil. So now let's take a look at the way that we manufacture the secondary winding of our transformers. And as I had mentioned earlier, the secondary of our transformers is actually a fabrication because it carries the cooling water of our water-cooled transformers. That process starts right here in our copper machine shop. And so at the same time, in the primary coil winding department, they start a set of primary coils. The team here in the copper machine shop is kicking off all of the components that are needed to manufacture that secondary winding. And again, it's comprised out of different pieces of copper bar stock, copper extrusions, and copper castings. When they're done with their machining processes, it goes to our brazing area where it's all put together to become that secondary. So after all of those copper parts are machined, they come here into our brazing area to be assembled. Two critical elements about our brazing. First off is the quality of the electrical connection that's made by the braze joint. To accomplish that, we use a high silver content brazing material. And the second element is that of leak-tight joints. Again, the water cooling of our transformers is in the secondary, and if any of those joints leaks and the water comes in contact with the primary, the transformer will fail. So to meet the exacting demands of the automotive industry and what it requires from its resistance welding transformers, we developed this cell where we assemble exclusively product that is used in automotive resistance welding. It also gave us an opportunity to rethink the entire design of the transformer and rectifier. And so today, we've streamlined that design and built an integrated rectifier with the transformer, streamlining many of the parts and the assembly procedures used. This has driven leading edge quality and a highly effective and efficient product. So in this part of the process is where we put the primary winding and the secondary winding together into a sub-assembly. What's really important here is tying off the electrical connections correctly. So all of these different coils have to be linked together. And the other really critical component is that the insulation system that protects the primary winding from the secondary winding has to be put in correctly. What's really interesting is that usually things that are good electrical insulators are also good heat insulators. But RoMan has developed a proprietary insulation system that is both a good dielectric, a strong electrical insulator, but allows for high heat transfer. And it's important that we get the heat out of the primary coils and into the secondary coil where the water cooling is. So after the primaries and secondaries are put together and the electrical connections are made, the final stage of the process is to fully cure the insulation, and that requires a baking cycle. So the primaries and secondaries are clamped under force and loaded onto carts like this, which are wheeled into the oven behind me for a 3 to 4 hour baking cycle, which fully cures the insulation. So after the primaries and secondaries come out of the insulation curing process, they come to this stage where there's a series of tests performed on them, both electrical and flow and leak check, to make sure that everything is correct, that we have the correct turns ratio, that we do not have any shorts either within the primary turns or between the primary and the secondary, and that all of the braze joints in the secondary are leak tight. Then an aluminum casting is mounted onto the transformer. It is kind of the foundation, the base at which the rest of the final assembly is based. And again, castings like this, which we produce in our own foundry. So let's go see how that transformer is assembled. So in our final assembly area is where all the components come together to make that finished transformer. And as I had mentioned earlier, everything that we build is build to order. And so we kit every job specific to what the customer has ordered so that our assembly technicians can quickly and efficiently complete the final transformer assembly. So I'm standing here in what is a kit, and we put them on carts so they're easy to move to the assembly benches, but it has all of the components and all of the information that the assembly technician needs. In that job router, it gives them the bill of materials, the amount of time that we have allocated to assemble the transformer, and all of the components and how they go together. And so here again, you can see the primary, secondary, sub-assembly with the aluminum casting mounted. In the case of this transformer, it uses a tap switch on the primary. It lets the customer select different voltages and all of the miscellaneous hardware that's needed to complete the assembly, and that including the magnetic core, which goes around the legs of the transformer. This is an example of what it looks like when it all comes together. This mid-frequency DC power supply is used in ring projection welding, which is another one of the many forms of resistance welding. So over the many years of building our transformer and power supply business, one of the competencies that we've developed in-house is our own fabrication capability. So this is a great example of a finished product from our fabrication group. In this particular case, it is the base and enclosure for a robotic welding cell. We've included the powder coating, so this can go to the integrator. They're going to put in the robot and the weld package and be welding in the industry in no time. Thank you for taking the time to tour RoMan Manufacturing. I hope you enjoyed it. I trust you could see the pride and skill that goes into the production of every transformer and power supply we produce. On behalf of the entire team at RoMan Manufacturing, thank you.